visit about fire protection system and aircon at Billion Seri Iskandar.
Billion Seri Iskandar is a well-known commercial centre in this area and plays as an important role in supporting local business activities. The building consists of various facilities such as retail shops, office space and services outlets that are frequently used by the public. Due to its strategic location and high daily occupancy, this building serves as an important hub for the surrounding community and contributes to the overall development of Seri Iskandar.
Okay, right now this is the one of the fire protection system in this mall. This consists of steel valve, nozzle, and also valve. The valve, when it's open, it will throw the water through this hose.
This is the door for the fire escape and we must really ensure it's always closed. The escape route that people we use to come out, and the stair must make sure it's wide enough for people to escape from the building, and however you also have ventilation. We see the exit sign and go through the fire door, and people are not allowed to use the lift when the fire is happening.
This is the manual call point, or also known as the fire brake. To activate this, you need to break the glass here, and it will activate the alarm above the brake glass, and the sound will spread throughout the mall.
So I want to explain right now the shutter used in this building. The shutter is used for prevent the fire to be spreading among the other part of the building.
This is a firefighter phone. It used to communicate between the firefighter and also fire control.
This is the fire extinguisher that is ABC powder type and it used for the small fire protection.
Okay, this is the external fire hydrant. The use of this will provide the firefighter a large amount of water during emergency fire. The firefighter will connect the hose to this outlet, and this hydrant will be supplied the water.
This is fire pump room that supplies water at sufficient pressure for fire protection. It consists of a jockey pump, main electric fire pump and diesel fire pump.
So why is a centralized system suitable for a mall? First, malls are big. There's a lot of open space, high ceiling, and many people inside. A centralized system can handle a large cooling load and keep the temperature consistent throughout the building. Second, it's more energy efficient for large buildings. Imagine using hundreds of split units. That would be noisy, messy, and expensive in the long run. And another reason is comfort. With centralized air conditioning, the cooling is more stable, quieter, and just feels better overall. As you can feel right now, the temperature inside is cool and comfortable, even though it's hot outside. This is because malls like Billion Seri Iskandar usually use a centralized air conditioning system.
But here's the interesting part. The system has some system called interdependency. What that means is every part of the system depends on each other. For example, the chiller produces chilled water, the pumps move the water, the AHU or air handling unit cools the air, and the ducts send the cool air into the mall. If one major component fails, especially the chiller, a big area or even the whole mall, it can lose cooling. So that's why malls usually have backup systems like multiple chillers or standby pumps. It reduces the risk if one unit breaks down. So one more important thing about the centralized beacon is the AHU, which is air handling unit. So we don't usually see it, but AHU plays a huge role in keeping this mall cool and comfortable. So here is a handling unit room, but unfortunately we can't enter this room because there is a lot here. But don't worry, I will briefly explain what AHU does and why is it important. And what does AHU do? First, the AHU main job is to cool the air. It uses water from the chamber system, and when warm air passes through the furnace coil, the air becomes cool. The second one is the circulate air. The ASU has a fan that pulls in the cool air from inside the mold and pushes the cool air back through the ducts. The third one, it helps with the air cleaning. Inside the ASU, there are filters that remove dust and dirt, making the air cleaner for shoppers. It also brings in fresh air from outside, which is important to avoid stuffy air and to keep oxygen levels clean. So why does ASU is important here? In a place like Belen Sri Iskandar, with large open spaces and many people, the ASU helps maintain comfortable temperature, clean air and proper ventilation. So in short, the ASU filters, cools and distributes air throughout the mall. Without the ASU, this place will not feel nearly as comfortable as EZP.
So this is the end of our video presentation today.
Thank you.
Hi, Assalamualaikum. So my name is Nur Asha Safir and our group will be presenting about the fire protection system and air conditioning system. In modern building design, mechanical system play a vital role in ensuring comfort, safety and efficient building operations. This system regulate the indoor environment and protect occupants from potential hazard. Among the most important mechanical services are air conditioning and fire protection system, which support both daily operations and emergency preparedness. When properly planned and integrated, mechanical system enhance the occupant comfort, safety, energy efficiency, and long-term building performance. For this case study, the selected building is Belen Shopping Centre Sri Iskandar, which is non-residential commercial retail building located in Bandar Sri Iskandar, Perak. The shopping centre is operated by the Belen Group of Companies, a well-established Malaysian retail founded in 1985. This outlet mainly serves a local residents, workers and students, reflecting Sri Iskandar role as an administrative and educational hub. Due to its high occupant density and long operation hours, effective HVAC, which is the air conditioning and fire protection system, are essential to ensure the comfort, safety and uninterrupted operations. In terms of fire protection, the system is a critical safety feature designed to detect, control and suppress fire to protect the occupants and property. It includes active systems such as fire detection and alarm system, sprinklers, hydrants, hose reels, and fire suppression system that respond automatically or manually during the fire incident. These are supported by a passive fire protection measure, including fire-rated walls, doors, partition, compartmentation, and smoke barriers, which helps prevent the spread of fire and smoke. Proper integration complies with the regulations and regular inspection and maintenance are necessary to ensure a reliable emergency response. Then the air conditioning system is a crucial mechanical system that maintains the indoor thermal comfort, air quality and humidity control, especially in hot and humid climates. The building uses a centralized air conditioning system where cooling is generated centrally and distributed through the top components of such as chillers, pumps, and handling units, fans, and ductwork. Since all components are interdependent, failure of a key component such as the chiller can affect the entire system. Therefore, the good system coordination and regular maintenance are essential to ensure the continuous operation, occupant comfort and energy efficiency.
Now I will explain how the system works to maintain the building internal environment. The first one is fire protection system. Active fire protection system include fire detection and alarm such as smoke detector and heat detector, and also manual calling point, continuously monitor environmental condition and transmit the signal to FSAP, fire alarm control panel. When the abnormal smoke density or temperature rise is detected, the alarm system will alert the occupant and automatically initiate emergency response. Next, suppression components such as the fire alarm system, automatically sprinkler, fire hose reel, and portable fire extinguisher that available in various types including water, foam, dry powder, gas, and chemical agent will be selected based on the class of fire involved. Those systems operate based on the principle of fire triangle. Active fire protection systems are designed to remove or control one or more of these elements, which is heat, fuel, and oxygen in order to suppress the fire effectively. For example, sprinkler system discharge water to absorb heat and lower the temperature of the fire, thereby removing heat from the element from the fire triangle. Next, passive fire protection systems are designed to control the spread of fire smoke without requiring activation, as the data collected from the site visit to present a fire-rated door and shutter function to restrict the spread of fire between building zones. Additional fire escape stair with ventilation component like wall opening serve to protect escape route to ensure the safe route during emergency and allow the smoke and the toxic gases are expelled from the building, including exit signage and emergency lighting to guide occupants toward the designated escape route and maintain visibility even during power failure. Next is air conditioning system. For this building, they use centralized system. The system typically operates through AHU air handling unit, which form the core of the centralized air conditioning system. Warm return air from the occupied space is drawn into AHU, where it passes through the filter to remove dust, airborne particle, and pollutant. The air then flows across cooling conduit supplied with chill water, where heat and moisture will be removed. Then the conditioned air will subsequently distribute back via ductwork and diffuser. Next, humidity control and air quality. The humidifier air will prevent condensation, mold growth, and material damage. It's important because it maintains relative humidity within the acceptable limit to reduce bacteria, fungi growth, and also sick building syndrome. It also ensures healthy indoor air quality. Next, air circulation and ventilation. Continuous air supply and return will prevent static air zone to ensure even temperature. Fresh air intake per ventilation standard will maintain the oxygen level and remove indoor pollutant. This will also support thermal comfort and occupant well-being. Control strategy. For fire protection system, control strategy is central control. Fire Alarm Control Panel FACP act as a central intelligence and command unit for the fire protection system. It connected to detection device like a smoke detector, heat detector, and manual call point. It detects fire accident to initiate emergency response automatically. Next is automatic and priority-based operation. Abnormal smoke or temperature will signal FACP to trigger evacuation. It will activate the separation system such as sprinkler to control fire growth early. Prioritize a life safety function, evacuation route is remain clear, and emergency lighting and exit signage illuminated. Next is reliability and compliance. It is designed for fail-safe and continuous operation during emergency. It is important to comply with the Fire and Rescue Department of Malaysia bomber regulation, and the system will undergo inspection, testing, and commissioning before the occupancy to ensure all functionality. Next is control strategy for air conditioning system. Zone level control. Thermostat monitor temperature and humidity in each zone. The aviation from set point will adjust chill water flow or fan speed in AHU or FCU. This ensures precise control for occupant comfort. Next is variable speed drive (VSD). It's used to supply and return fans, chill water pumps, and condenser water pump. It adjusts motor speed based on the real-time demand. It also benefits to reduce energy consumption, minimize mechanical wear, and improve system efficiency. Next is building level control, which is used in building management system (BMS). It will centralize monitoring and optimization of temperature, humidity, airflow, and energy. It function to include scheduling operating hour, adjusting set point, monitoring energy use and detecting fault, and also supporting prevent maintenance and trend analysis.
Assalamualaikum everyone, and now I'm going to explain to you the system suitability and interdependency analysis. And we will start by looking at why a centralized HVAC system is the optimal choice for this project. When we evaluate the infrastructure requirements for a large-scale commercial building, a centralized approach is almost the most suitable. This system are specifically engineered to support high occupant density and the rigorous demands of continuous 24/7 operation. Beyond just temperature control, a centralized system significantly improves indoor air quality through superior filtration and ventilation. From a design perspective, it reduces visual clutter on the building's exterior and minimizes noise for the occupants. While we must acknowledge a higher initial capital cost, it is a strategic investment that results in lower long-term operational costs. Transitioning to life safety, let's discuss fire protection systems and why they are so vital. In high occupancy public buildings, these systems are not just a feature, they are an essential requirement. Our primary goal is early fire detection to ensure we can react before a situation escalates. Furthermore, we utilize smoke extraction systems to limit dangerous smoke accumulation, which is the leading cause of injuries during fire incidents. By utilizing an integrated fire alarm system, we enable a rapid coordination emergency response. It is important to note that every element of the design is specifically tailored to comply with the Malaysian fire safety regulation. The core of our analysis lies in the interdependency between the HVAC and fire protection systems. They are not separate entities, they are linked through a sophisticated HVAC fire protection interlock mechanism. This interlock allows mechanical system to respond automatically without the need for manual intervention, which is critical during the panic of an emergency. Here is how that sequence unfolds. The process begins immediately when a fire is detected by smoke or heat detectors. A signal is instantly relayed to the fire alarm control panel. The system then triggers the automatic shutdown of AHUs, or known as air handling units, in the affected zone. This is a vital step in the prevention of smoke spread through the air conditioning ducts, which could otherwise transport toxic fumes to other parts of the building. Simultaneously, the system shifts into an active defense mode. We see the activation of smoke extract fans in the fire-affected areas to pull smoke out of the building. Finally, the system initiates the pressurization of staircases and escape corridors. By creating a high pressure zones in these areas, we prevent smoke from entering the exit routes, providing a clear path for occupants to evacuate safely. So in conclusion, the synergy between these two systems ensures that our building is not only comfortable but remains a safe environment in the face of an emergency.
I will continue explaining about the energy sustainability and efficiency. A key component of sustainability is energy efficiency, which emphasizes utilizing less energy to accomplish the same task while reducing environmental effect. Enhancing energy efficiency in buildings entails planning, running and maintaining HVAC systems to use less fuel and electricity without sacrificing tenant comfort or functionality. Sustainable energy methods encourage long-term environmental responsibility by lowering operating costs, conserving natural resources, and reducing greenhouse gas emissions. Buildings can dynamically optimize energy use by integrating energy-efficient technology like solar panels, LED lights, smart meters, and sophisticated HVAC systems. Furthermore, energy efficiency fosters a comprehensive approach to environmentally conscious building management by supporting other sustainability objectives, including waste reduction, water conservation, and enhanced indoor environmental quality. Energy efficiency directly helps to both financial savings and ecological protection by lowering energy demand and dependence on non-renewable resources. I will now continue presenting about the Billion Sri Iskandar fire protection system. In large-scale facilities such as Billion Mall Sri Iskandar, high occupancy levels and diverse retail activities increase both the risk and potential impact of fire incidents, making an effective fire prevention system essential. Conventional fire safety systems that rely on manual sprinklers and basic smoke detectors often lack the responsiveness and efficiency required for modern sustainable buildings. Implementing a smart automated fire detection system integrated with intelligent sprinklers significantly enhance safety and resource efficiency. Smart sensors detect smoke, heat, and abnormal temperature changes in real time, activating sprinklers only in affected areas and sending immediate alerts to the mall's monitoring system. This target response minimizes water wastage, reduces damage to surrounding areas, and protects building assets and inventory. Additionally, smart systems reduce false alarms, lowering maintenance needs and operational disruption. Overall, a smart fire prevention system supports cost efficiency, environmental sustainability, and long-term building management while ensuring the safety of occupants and tenants. Billion Sri Iskandar Heating, Ventilation and Air Conditioning System. A retail mall's HVAC system plays a crucial role in both indoor environmental quality and energy consumption. At Billion Mall Sri Iskandar, the conventional centralized HVAC system cools or heats the entire building uniformly, often leading to energy inefficiency and overconditioning of low occupancy areas. Replacing the system with a variable refrigerant flow system combined with energy recovery ventilation offers a sustainable solution. VRF allows precise temperature control across different zones based on a real-time demand, while ARV recovers energy from exhaust air to precondition incoming fresh air, reducing cooling and heating loads. This combination significantly lowers electricity consumption and carbon emissions. Beyond energy savings, VRF and ERV systems improve indoor air quality and occupant comfort by providing consistent thermal conditions and fresh, filtered air. Their modular design also reduces long-term maintenance costs and extends system lifespan. Overall, adopting VRF and ERV systems supports energy efficiency, occupant well-being, and the mall's long-term sustainability goals. I will conclude this video presentation by explaining the conclusion. First, the building service at Billion Shopping Centre in Sri Iskandar are well designed to support its role as a high occupancy shopping complex. The systems are suitable for handling a large number of occupants throughout daily operations. Next, the centralized air conditioning system provides comfortable indoor temperatures, proper ventilation, and acceptable indoor air quality. This is important because the shopping centre operates for long hours and experiences varying internal heat loads. In addition, the fire protection system focuses on occupant safety. It includes early fire detection, fire suppression, smoke control, and safe evacuation methods, all of which comply with Malaysian fire safety regulations. Furthermore, the integration between the HVAC and fire protection systems improves safety during emergency situations. For example, air handling units are shut down and smoke extraction systems are activated when a fire is detected to control smoke spread. Overall, the coordination of these building services system shows that the building can operate efficiently during normal conditions while remaining safe and reliable during emergency.